All right. Hello, everybody, and good morning, good afternoon, and good evening to wherever you are. It is December 7th, 2023, and we're going to be doing the Advent of Cyber challenge for day 7 from the TryHackMe website. If you don't know about this particular website or this particular challenge, I'm going to drop a link in the chat for you all, and you can check it out if you have not already. All right, so with that out of the way, let's jump into today's challenge. Okay, so today is a blue team oriented log analysis challenge. All right, so the first thing we do whenever we start up our TryHackMe Advent of Cyber challenge is we need to start the machine, the virtual machine that is going to be used in today's challenge. You can do so by clicking on the green Start Machine button up here. All right, that's going to split the page into a split screen view. But while that virtual machine is initializing, let's go back up to the top of the task and let's take a look at our learning objectives for the day. I'm Shy Hat, by the way, the Shy Hat, if you guys didn't know already. So in this task, we'll be focusing on the following vital learnings to assist Forensic McBlue in uncovering the potential incident. We're going to revisit log files and their importance. We're going to understand what a proxy is and breaking down the contents of a proxy log. We're going to build Linux command line skills to parse log entries manually, and we're going to be analyzing a proxy log based on typical use cases. All right, so that's quite a few objectives. So let's start with our log primer over here. Before analyzing a data set of proxy logs, let's first revisit what log files are. A log file is like a digital trail of what's happening behind the scenes in a computer or software application. It records important events, actions, errors, or information as they happen. It helps diagnose problems, monitor performance, and record what a program or application is doing. For clarity, let's take a look at a quick example. So we've got this example log file entry right here. It looks like a networking log, so it shows what happened at what time. So we've got these fields right here. So we're going to break them down below. The example above is an entry from an Apache web server log. We can interpret it easily by breaking down each value into its corresponding purpose. So we have this portion right here, which is the source IP address, the source computer that initiated the HTTP request. We have the timestamp, which is this right here, the time and date where the event occurred, the HTTP request. So this value right here is the actual HTTP request made, including the request method, URI path, and HTTP version. Okay, and we also have the next part, which is the status code, which is the response to the web application. There are a lot of different status codes according to what happened in the transaction. And the last one we have is the user agent. So signified by this right here. The user agent used by the source of the request. It is typically tied up to the application used to invoke the HTTP request. So in a lot of cases, this is going to be a web browser or some other application that is used to make an HTTP request. So before we move on, we're going to move the virtual machine into its own web browser pane. We can do so by clicking on this portion, this button right here. It's called View in Full Screen. And we can click on that, and that's going to open up a new browser tab. And the new browser tab means that we can get a much larger view of the virtual machine, which is convenient for us. So we're going to go back to the original web browser, the web browser tab here. Okay, and then we're going to close this version of the virtual machine by clicking on this button right here, which is called Exit Split View. All right, and now we can take a look at the text nice and big again. I'm going to magnify it a little bit so that we can read altogether. Okay, so where were we? So we just took a look at the various components of this log file entry right here. So being able to interpret a log entry allows you to contextualize the events, whether for debugging purposes or for hunting potential threat activity. So next we're going to take a look at what is a proxy server. Since the data to be analyzed is a proxy log, we must understand what a proxy server is. So a proxy server is an intermediary between your computer or device and the internet. When you request information or access a web page, your device connects to the proxy server instead of connecting directly to the target server. The proxy server then forwards your request to the internet, receives a response, and sends it back to your device. To visualize this, we're going to refer to the diagram below. Okay, so when we have a proxy server and a user tries to access google.com, the device is going to reach out with its web request to google.com. Oh, sorry, without a proxy server. So this is without a proxy server, so your device is connected directly to google.com. But with a proxy server, the user attempts to access google.com and the connection request passes through a proxy. So the proxy server is in between the user's device and the final destination that you're getting information from. So it serves as an intermediary or a middle device to send messages back and forth between the user and the target website. A proxy server offers enhanced visibility into network traffic and user activities since it logs all web requests and responses. This enables system administrators and security analysts to monitor which websites users access, when, and how much bandwidth is used. It also allows administrators to enforce policies and block specific websites or content categories. Given that our task is hunting suspicious activity on the proxy log, we need to know what potential malicious activity can be seen inside one. So that is the log. Let's elaborate on a few common examples of malicious activities. So one attack technique is download attempt of a malicious binary. And how we can see an indication of this is connection to a known malicious URL binary. So for example, we're trying to connect to this malicious.exe binary over here. That's no good. Okay, the next case is data exfiltration. So that's an attack technique. And the potential indicator is a high count of outbound bandwidth due to file upload. For example, outbound connection to OneDrive. So this is data exfiltration. You're trying to get data out of a network. So maybe you've got some juicy data that you're trying to get out of a network that you've compromised. You would do so through data exfiltration. Okay, and the last category that we see here is continuous C2 connection. So a C2 connection is known as a C2 is a command and control, and it is usually a server that malicious parties use to try to give commands to a compromised host. So say that you get hacked, and then the hacker decides to set up a connection between your computer or your device and their C2 server, which they use to issue commands to your compromised device. So the potential indicator there would be a high count of outbound connections to a single domain in regular intervals. Okay, so we're going to expand further on these concepts in the following task sections. All right, so accessing the data set. Before moving forward, review the questions in the connection card shown below. All right, so do we need to start the attack box today? No. Do we need to start a VM today? Yes, and we just did that previously. Is there split screen available? Yes, but we've decided to put the split screen in its own browser tab for convenience. Is there a direct link available? No, and we are not given credentials to connect directly to the VM via RDP, VNC, or SSH. So we must understand the log contents to work on the dataset provided to make things fun. Let's start playing with it by clicking the Start Machine button in the upper right corner of the task. We've done that. The machine will start in a split screen view, If the virtual machine isn't visible, use the blue Show Split Screen button at the top of the page. The VM contains a proxy log file in the home Ubuntu desktop artifacts directory named access.log. You can verify this in the terminal icon by clicking on the terminal icon on the desktop and executing the following commands. Okay, so we're going to open up a terminal in our virtual machine. So we're going to go to the virtual machine tab, and then we're going to open the terminal with either this button, or this button. So we're going to use this button here, and we're going to open up a terminal, and I'm going to make it nice and big for everybody so that we can see exactly what is going on. Okay, that's nice and big. So what we need to do is we need to navigate to the directory that was indicated. We can do that by copying this command right here, cd artifact desktop artifacts. Okay, Control C to copy. And inside of the terminal here, we can use the Control Shift V shortcut to paste it in, and then press Enter. And then we can use the ls-la command to list out the directory contents. And we can see that the access.log file is here. So chopping down the proxy log. So log McBlue tells us that he has configured the Squid proxy server to use the following log format. Okay, so every entry in this log is going to take this format here. Timestamp, source IP, domain, port, HTTP method, HTTP URI, status code, response size, user agent. So for example, we've got this example over here and its corresponding values. So we'll take a look at this one right here. So the timestamp in this example is this. The source IP is this IP address. The domain and port is storage.live.com on port 443. The HTTP method is the get method. The HTTP URI is the default one. The status code for this one is 400, and the response size is 630. Lastly, the user agent used in this example here is Mozilla.5.0. So Mozilla.5.0 is Firefox, I do believe, and so that means that the request was made by a Firefox web browser. So as you can see in the table above, we can break the log entry down and assign a position to each value so that it can be easily interpreted. Now let's continue by using another Linux command line tool to split the log entries per column, and this is the cut command. So the cut command allows you to extract specific sections or columns of lines from a file or input stream by cutting the line into columns based on the delimiter and selecting which columns to display. This can be done using the -D option for delimiter and the -F option. The example below uses quote space quote as its delimiter and only displays the timestamp column 1 after cutting the log with space. Okay, so if we cut and paste this command into our virtual machine, Control C to cut, Control C to copy rather, and then Control Shift V to paste, and we run this command, we see that we only receive the timestamps for all of the entries. Not super useful, but it gets the job done. Okay, it's also possible to select multiple columns, just like in the example below, which chooses the timestamp column 1, domain, port column 3, and status code column 6. So this following command is going to retrieve the timestamp, the domain, the port, and the status code. So we copy this command, Control C, in the virtual machine, Control Shift V, and we run the command. And so we get the timestamp and the domain and the port and the status code for all of these entries. Lastly, the space delimiter won't work if you plan to get the user agent column, since its value may contain a space, just like in the example log. Okay, so we can't use the delimiter space because there's a bunch of spaces in this one particular column. So given this, you must change the delimiter and select column 2 because the user agent is enclosed with double quotes. All right, so if we wanted to get the user agent, we would have to use a command like this. So we can copy this and then paste it in, Control-Shift-V. So this retrieves only the user agent column. And we can see that we've managed to retrieve all of them despite the fact there's a bunch of spaces in here. All right. So in the example above, we use column number 2, since column number 1 will provide the contents before the first use of double quotes. So try executing cut D, this particular command, and see how the output differs from the space delimiter. Okay, so we copy that, and then we run it inside of the terminal. Okay, so we see that this output is different from when we just use the space as the delimiter, because it also allows us to see spaces inside of the individual columns. So next we'll talk about Linux pipes. So the ability to use piping inside of Linux is a very powerful tool, and so let's talk about this. In the previous section, we introduced some Linux commands that can be useful for investigation. To utilize all of these commands and produce an output that can provide meaningful information, we can use Linux pipes. In Linux or Unix-like operating systems, a pipe, or this particular character, is a way to connect 2 or more commands to make them work together seamlessly. It allows you to take the output of one command and use it as the input for another command, and we'll introduce more commands by going through some use cases. So for example, in this first case, we want to get the first 5 connections made by this particular IP address. To do this, we'll combine the grep command with the head command. So grep is a command in Linux that is used for searching text within files or input streams. It typically follows the syntax grep options, string to search, and then the file name. So let's use the command to focus on the connections made by a specific IP by executing this command right here. So we're going to copy that. To limit the display to the first 5 entries, we can append, so to limit the display to the first 5 entries, we're going to append pipe head-n5 to that command to achieve our goal. All right, so we can copy this command right here. And copy that, and then paste it in. So we get the first 5 entries where this particular IP address is involved. So we can see that this particular IP address connected 5 times to these different endpoints right here. All right. The first command's output may have been a little too overwhelming since it provides every connection made by the specific IP. Meanwhile, appending a pipe with the head command limits the results to 5. Okay, the second thing we're going to do with pipes is to get a list of unique domains accessed by all workstations. So to do this, we're going to combine the sort and unique commands with the cut command. So sort is a Linux command used to sort the lines of text files or input streams in ascending or descending order, while the unique command allows you to filter out and display unique lines from a sorted file or input stream. So note that the unique command requires a sorted list to be effective since it only compares the adjacent lines. To achieve our goal, we're going to start by getting the domain column and removing the port. When we have a list of the domains, we'll sort it and get the unique list using the sort and unique commands. All right, so we're going to use this command right here. Copy that. And then we're going to paste it in and run the command. Okay, so here we've gotten all of the unique domains that were accessed by the proxies, and we've eliminated any duplicate entries inside the list. So it's a lot of different domains still. Okay, moving on. You can try to execute commands one at a time to see the results before adding a piped command. All right, so the third thing we're going to do with pipes is number 3, display the connection count made on each domain. So we already have a list of unique domains based on our previous use case. Now we only need to add some parameters to our commands to get the count of each domain accessed. So this can be done by adding the -c option to the unique command. So the -c command is going to provide a count of how many times this particular line appeared in the list. So if we copy this command and then run it inside of the virtual machine, we can see that these various domains were accessed this many times inside of the log file. Moreover, the result can be sorted again based on the count of each domain by using the -n option of the sort command. Okay, so we can, so this is the same as the previous command, only another sort command has been inserted, and in that way we can sort out the output and get the number of times it appears for each domain. So we can see here that the number of domains, the domains and the number of times they've been accessed has been sorted into descending order, with the largest numbers at the bottom of the list. So based on the result, you can see that the count connections made for each domain is sorted in ascending order. Oh, it's ascending order. Sorry about that. If you want to make the output appear in descending order, use the -r option. Note that it can also be combined with the -n option, -nr if written together. Okay, so just like this, we're not going to run the command because it's a bit of a pain. You can play with all the above commands to test your capabilities in combining Linux commands using pipes. So hunting down the malicious traffic. So we're getting into the main part of today's challenge here. So now that we've developed the skills needed to assist Forensic McBlue, let's get down to business. To start hunting for suspicious traffic, let's try to list the top domains accessed by the users and see if the users accessed any unusual domains. You can do this by reusing the previous command to retrieve the connection count for each domain and add pipe tail -n10 to get the last 10 items. Okay, so let's run this. So we can see here, so these are the most commonly accessed domains here. All right, with the most commonly accessed domains having somewhere in the neighborhood of 5,000 connections. Note that we use the command tail -n10 since the list is sorted in ascending order, and because of this, the domains with the high connection count are positioned at the end of the list. Check the list of domains and you'll see that Microsoft owns most of them. Out of the 10 domains that we see, one seems unusual. So let's use that domain with the grep and head commands to retrieve the first 10 connections made to it. Okay, so what is the suspicious domain? If we go over here and we take a look at these different domains, it's a lot of Microsoft related ones. So this is Microsoft, and so is this one, and so is this one, and this one, and this one, and this one. And not this one, but this one and this one. This particular domain stands out. So frostlings.bigbadstash.thm. So we can use the grep command with this particular domain name and see what those particular logs are. So grep and then this particular domain, access.log, and then head the first 5 entries. So let's do that. So copy this, and then we're going to paste it in. And then in the place of suspicious domain, we're going to replace the one that we've identified, which is frostlings.bigbadstash.thm. And these are the different entries. Well, this is the first 5 entries for this particular domain. And we can see here, upon checking the list of requests made to the redacted domain, we see that there's something unusual with the strings passed to the goodies parameter. So let's try to retrieve that data by cutting the request URI with equals as delimiter. So we're going to try to see what we get if we only get what is inside of the goodies parameter. So we're going to copy that, and we're going to replace suspicious domain with the frostlings domain. And we see a bunch of alphanumeric characters right here. So what is the significance of this? We're going to be explaining that in just a bit. So based on the format, the data seems to be encoded with base 64. Using this theory, we can try to decode the strings by piping the output into a base 64 command. So it's the same command that we did previously, only we're going to append to it this right here, pipe base64-d. All right, so in the virtual machine, we can just press up to access the command history, which gives us previous command, and then space pipe base64-d. And then we run that command. And we see here there's a bunch of hex characters right here, and then there are names, and then there looks like different toys or presents that people want to get. All right. So did you notice that the decoded data seems to be sensitive data for Antarctic crafts? This might be a case of data exfiltration. So in the conclusion, it says, congratulations, you have completed the investigation through log analysis and uncovered the stolen data. The next step for Forensic Clues team is to apply, in this incident, is to apply mitigation steps, like blocking the malicious domain to prevent any further impact. So we're going to answer the questions below using some of the commands that we learned in today's lesson. So how many unique IP addresses are connected to the proxy server? So we can get this. This answer by using the following command. So this one is cut D, and then we're going to cut D by space, and then we're going to get the second field, I guess it is, in the access log, and then we're going to sort. We're going to sort it, and then we're going to get unique entries, and then we're going to get a word count. But before we get the word count, let's just run this without the word count. So we see that we have a list of different IP addresses here. But if we want to count them, we can use the WC command, so for word count with the pipe command. And we can see that it says that there are nine lines here, so this is 9. In the case that this was a really long list, we could use the WC command to get the number of lines here, so it's 9. So we go back here, we punch in 9 as the answer, and submit. Okay, the next question is how many unique domains were accessed by all workstations? So we can use the following command to get the answer there. We go to our machine and we paste this in. This is cut D by spaces, and it is the third field in the access log. And then we cut D again, and then we separate it by the colon, and we only get the first field. And then we sort it, and then we get rid of all the duplicate entries with unique, and then we get the word count. But before that, let's see what it is before the word count. Okay, so it's all of these different domains. There's a lot of them, but we can run the command again, but with the word count, WC, and we can see that from the word count, there are 111 lines. So that is the answer. So the number is 111. What status code is generated by the HTTP request to the least access domain? So first of all, we need to find out what the least access domain is. So what we can do is we can go back here, run the previous command, up to this point, and then we can it's head and then number, right? Head and 5. Okay, I think we need to also sort and unique them, and then head and 5. Let's see, head and unique, and then C for count, and then head and 5. Wait, I think we I think we also need to sort it again. Okay, so so that's it. So this is the least accessed domain, and then we're going to get the answer for this one with the grep command. So grep and then partneredservices.microsoftkey.com, and then the access log, and then pipe in head and 5, and we're looking for the HTTP code, and it is this right here, 503. So it's a 503 code on all of them. So that is the answer, 503. All right, so based on the high number of connection attempts, what is the name of the suspicious domain? So if you remember from our example back there, it was frostlings.bigbadstash.thm. Okay, the next one is, what is the source IP of the workstation that accessed the malicious domain? All right, so we can get the answer to that by using the following command. So this one is another grep command, and then we're going to grep for frostlings.bigbadstash.thm access log, and then we're going to cut the output of that, and then we're going to get the second field, which is going to return the IP address. So the IP address is this one every time. So we can copy this one. So Control-Shift-C to copy that from the terminal. And then we can paste it in here to submit the answer. So how many requests were made on the malicious domain in total? So how do we get the answer for that? The answer is found with this command right here. Control-Shift. So we're going to use a cut-d command on the access log, and we're only going to retrieve the third field on there. And then on that one, we're going to cut d again to only retrieve the domain and not the port. And then we're going to sort it. We're going to unique with the count, and we're going to sort that again. So the malicious domain is this one right here, frostlings.bigbadstash.thm, and there were this many connections to it. So 1581, and that is the answer. Okay, so having retrieved the exfiltrated data, what is a hidden flag? So we need to use this particular command right here. Just a second. To get that answer. So it's this command right here. So we're going to grep for this domain right here in the access log, and then we're going to get the base64 encoded data with these two cuts, and then decode it with this base64d command right here. And then we're going to grep that with the THM. So we all know that THM is the beginning of all of the official flags in the TryHackMe's service. So if we grep for this, we're probably going to get the flag. So we run the command, and we see this is the answer right here. THM, a gift for you, awesome analyst. So we can copy that, and then use Control-Shift-C rather to copy, and then go back to the answer field, paste it in, and submit. Okay, so we've essentially finished the room. We just need to click on this. All right, and we finished the exercise for the day. Before we go, I'll just take this opportunity right here to plug my YouTube channel, youtube.com/TheShyHat. Oh, sorry, @TheShyHat. So on this page, if you want to learn more about Linux and running Linux commands, we have our red series right here. So these videos with the red thumbnails right here, these are all about using Linux. If you're a beginner, these are very useful. So here, Linux OS Operations 1, Linux OS Operations 2, and Linux OS Operations 3. So we cover a bunch of using basic Linux commands, and we also cover how to open up a terminal on your Windows machines to access those. So that is all for today, day 7 of Advent of Cyber on TryHackMe.com. But we'll be back tomorrow, where we're going to be doing day 8. Please join us again next time. Until then, have a great day, and we'll see you next time.